So hi everyone. My name is Iffy. I'm an environmental engineer, toxic reduction engineer with the state of Washington, Department of Ecology. And we're spending a few moments talking about Lean and Green and the project that we did with one of the more or less one of the companies that I worked on here in Washington State, and what led to significant cost reductions and also reduced environmental impacts as well. Yeah, so basically I'm just going to talk about the principles of lean, what it's about. Also going to talk about a case study on what we worked on, which is for a particular company called Founder's Choice Cabinets out in Washington State. Basically, we're going to talk about lean, the overview of lean, the impacts on the environment, the partnership that we had with Ecology and Impact Washington, some of the lean tools and strategies, and then a case study, more or less a case study that we did with Founder's Choice. And then I'm going to wrap up with some recap and conclusions. So lean overview. What is lean? So basically, usually you have, in a process, you have what is value added and non-value added. Value added activities are usually activities that, change the form of the product, and then non-value added activities don't necessarily add any sort of form or function to the product. So anything that's non-added in a process is known as waste. And the entire purpose of lean is to try to eliminate or reduce this waste that you would find in the process. So that's what lean is about. In terms of the lean overview, right? About 95% of a lot of production lead time can be non-value added, which is really huge. I mean, if you think about the entire process and how much time actually is spent on non-value added activities, that's relatively a large amount of waste that could be eliminated. And the aim of eliminating this waste is to try to shorten that lead time between, customer order all the way down to product shipment. So if you can kind of like eliminate those wastes, that's literally just going to reduce the time, and you'd get a faster and much more efficient process to be able to send your products out the door, right, to, the basic target audience. This is a video I included on here.
Let's say your business is doing well and you're thinking of expanding. That's great, but it's also the riskiest time for your business. In fact, many businesses don't survive the transition. Should you throw money at the problem by investing in new equipment or hiring more people? Should you make your staff work more overtime? Your answers to questions like these can make or break your business. And that's where lean comes in. Lean is a philosophy about delivering value from your customer's perspective, eliminating waste, and continuously improving your processes. Lean can radically change the way you do business. Lean management is based on 4 principles. The first principle is pull. Rather than producing as much as possible, customer demand pulls goods or services through the manufacturing process. This minimizes overproduction, inventory, and ultimately working capital. The second is one-piece flow. Focusing on one single piece at a time minimizes work in progress, process interruptions, lead and waiting time, while increasing quality and flexibility. The third is tact. It's the heartbeat of a lean system. It's how fast you need to manufacture a product to meet customer demand. Tact allows us to balance work content, achieve a continuous flow, and respond flexibly to changes in the marketplace. And the fourth is zero defects. Mistakes happen, but a lean company doesn't pass on defects. Mistakes from previous steps must be fixed before going on. Combined with a robust continuous improvement process, the 4 principles of lean management will help your company stay ahead of the competition in a constantly changing marketplace. So, if you're ready to begin your lean journey, contact us today. Let us show you how lean can bring out the best in your business.
So the lean 8 ways, right? And I usually use this acronym known as downtime. It's defects, overproduction, waiting, non-utilized talent, transportation, inventory, motion, and extra processing. And I can just run through quickly what each of these 8 ways is about. So defects, basically, you have work as kind of like rework or scraps that you have that you actually find out in the process. And if you have a lot of scraps that's being produced, basically you have much more raw materials that is needed, and actually is mostly consumed in making a defective product. And also these defective products, you end up having to dispose them, which is more materials that's disposed than needed for the environment. Second one is overproduction. If you're overproducing something, basically it's overproducing much more than is needed. And because of that, you can see a lot of things like, more materials being used or more energy than is necessary to produce a product. Or sometimes you might have even extra products that become obsolete and then they require disposal as well. On the waiting side, waiting is basically just time waiting for the next step of the process. And it leads to things like, potential material spoilage. Or even sometimes the more materials is waiting, you have a lot of wasted energy from heating or cooling. And that's a whole bunch of waste that needs to be accounted for. You also have transportation. Basically, it's the unwanted movement of, or actually unnecessary movement of people and materials. So the more unnecessary movement of materials you have, that's more emissions from transportation, that's more energy use as well, and then it can also lead to certain damages and spills. Inventory basically is excess material and materials that's not processed. It can lead to things like more materials being that is needed to replace any sort of damaged work in progress. And also, if you're storing more and more products, that's more energy that is used to heat or cool that inventory space than is necessary. Extra processing too, similarly, is more work than necessary that is required from a customer. And then because of that extra processing that's being done, you have more parts, more raw materials is being used. And also you have a lot of like unnecessary processing and wastes and energy and more emissions as well. So literally from everything we've talked about, there is an impact. There's a way we see how this waste impact the environment. And this kind of led us to develop this partnership, which is the Lean and Green partnership between Ecology and Impact Washington, where basically, Ecology, we work with certain facilities to review what the processes are, what the environmental impacts are, and then what we can do to reduce those impacts. And we try to track these in terms of reduction matrices. And then Impact Washington, who is our manufacturing extensive partner, we partner with them to lead events like this on Lean. We try to develop project scopes and then for more or less use the expertise to be able to deliver the trainings that we have to these different facilities. So that's how the partnership came about. And we've used a whole range of Lean tools and strategy. We've used things from, process assessment, value stream mapping, all the way down to Kaizen, which is actually the implementation of the direct continuous process improvement. A lot of all these things, a lot of Lean methodologies are targeted towards pollution prevention, which is why we came up with that term Lean and Green. So if you do things like, standardized work, 5S systems, plant layouts, quality at the source, all of these are semi-items that you use to contribute towards your lean work. And if, as you can imagine, if you work in a much more lean and efficient way, that's a reduction of materials, that's a reduction of energy, that's a reduction of maybe even chemical usage that would have been helpful to the environment. And all of these serve towards pollution prevention. So that's the primary goal, and that's what we're really strong proponents for. So basically, we started out working with the facility from the process assessment side. We interviewed the different folks in the facility that is founder's choice. We talked to people from management, scheduling, supervision, milling, finishing, assembly, and quality control. Basically, founder's choice, what they do is that they produce cabinets, and over time they had been having issues with a lot of defects that they'd be having on the parts, and that's actually been building up across the entire process chain and really impacted how much they were disposing as hazardous waste and much more raw materials that were using than necessary. So this was a perfect candidate for us to work on Lean, and we tried to train them by getting some initial information as to what they were doing in the process and identify any of the bottlenecks in that process as well. So yeah, this is a case study for Founder's Choice. We started out with value stream mapping, and basically we tried to visualize that process. As you can see, everything down from raw material reception all the way down to assembly and shipping. And then we also calculated how much paint material waste that they had and VOC emissions which is around 18,620 pounds a year for paint waste, and VOC emissions of about 16.6 tons a year. So basically, a lot of the things that they do, when they're milling and even painting in the finishing area, imagine when you're spraying painting a particular part, you're going to be emitting a whole lot of VOCs because paints have a lot of volatile organic compounds, which are really harmful to they can be harmful to the ambient environment and also to employee health. So we're looking at ways to minimize these waste and the effects. So one thing we did was that we started at improving how the paint is painted, and we did what we call the spray efficiency training. And basically, it's just a way to help facilities understand the best way to apply aerosol paints on a part. And that way you can minimize, overspray, which also leads to reduction of VOCs and all these harmful emissions that staffs would have. But also it improves the job, the hand job on the particular part as well. Another thing that we looked to recommend and implement was a plural component spray system. And that spray system really is a way that it's a better way of, it's like much more an automated way of pre-mixing your paint and your catalyst, so that you don't necessarily have to hand mix it yourself. And what that does is that instead of hand mixing, you actually optimally pre-mix your paint items and you can spray the part. And because of that, you're literally reducing, a lot of paint application time. So that's definitely less labor time and also less paint waste that you generate because you only use the amount that you need. So all of that, the implication is that by implementing this, we're looking to save the facility over $40,000 in waste management, but also reducing the entire waste that it generated by 20%. This is a video that is on here, and you'd see that on the link as well. Definitely feel free to click on it and you'd see how the process actually works. We also did things like energy efficiency. Basically, we looked at how to implement variable frequency speed drives so that the facility are able to utilize the air compressors only when they need it. And they can regulate the motor speed at the times, maybe during peak times and lower peak times, so that they end up saving at the times when they don't necessarily have to spend much energy versus just running their compressors at a fixed speed, and they start to pay a particular fixed speed of a fixed amount every month in terms of the usage. We looked at things like LED lighting, basically just installing LED lighting to be able to have them much more energy efficient with the electricity. Another thing we did was on the waste management side. We worked on making sure that whenever they are running a solvent installation still, we made sure that they implemented a latch, making sure that, and also having a gasket to make sure that there's any sort of vaporization that occurs is minimized. Thereby, you don't have any sort of like vapor leaks that you get from your solvents that would be really harmful to employee health. We also help them determine the best way to flush their paint so that they only flush the amount of paint that they use and continue to spray, and then reduce how much, overspray or at least overflush that they have over time. Basically, with that, they're literally saving, about 50% of solvent waste actually, because they're only mixing and using what they necessarily had. So that's one good thing that came with the fluoro component spray system that we had indicated earlier. This is just a graph, or at least a chart that shows kind of like the time study that we did on the painting assessment side, everything that they did from racking of the cabinets all the way down to unracking and leaving the cabinets in the kit cart. We measured the cycle time, and you could see that the highest bottleneck in the entire process was drying the primer. So what we thought about was that what we could do to improve the way that they dry their particular parts. So some things that we talked about was implementing an automated rack. So at least that way, whenever they have their cabinet parts, they left in ambient air to dry. So that as they're pre-dried, they can then be used and staged in the next batch, instead of having to wait for each particular cabinet to be dried, and that's going to be causing more and more bottleneck on the other part of the process. Another thing was that we looked to see if they can have a dedicated particular booth, just like a sort of electric drying booth where they can dry both their paint and stained particular cabinet parts. You can put it all in one particular booth, and then they can run in one cycle instead of having each part dried and individually used over and over again. So this was one thing we thought about. And with this, you can literally significantly reduce staff wait time, and you can also improve how much cabinets are being dried and moved out to the kitting cart over time. So that was one thing we were looking into. We also tried to modify how the carts looked, so that the carts could you could stage as much cabinets that is needed for the job in one cart, and then you can roll it into the dryer so that you'd have less waiting time for your staff. But also it improves ergonomics, because you don't need to have your staff like holding each cabinet and then physically dragging it out to the paint booth. That actually improves the ergonomics over time for staff. We also talked about 5S. Basically, 5S is a standardized process where you look to sort, set in order, shine, standardize, and sustain. Basically, what that is that you're looking to eliminate any sort of material that you don't necessarily need, arrange all the items that you need in a particular clean space so that they can be easily accessible to staff. And by doing this on a regular basis and making it a standard for staff, you're starting a culture whereby there's a standardization and there's less waiting time in between work that needs to be done for staff to have the necessary tools that they need to do the job. So that was one thing that we talked to them about. We started to do some of this, like, putting on visuals, like making sure like we had them put on posters on how to inspect the dangerous waste. We put it on there, and then whenever they had like paint, for example, that they had open without any closed lids, we had them move it out and stage it into the particular segment of the plant that has, the visuals on how to store their paint, and make sure that it's in a secondary container so that you can minimize any sort of leaks or damages that would happen over time through the opening of this hazardous paint materials. We had them, install secondary containment, and then also we had them get a spill kit so that they had it on site that they could be able to use to clean any sort of hazardous chemicals or hazardous waste that would have spilled up, and then they can dispose of it over time. They were provided the appropriate PPE, so the personal protective gear. We tried to track the performance metrics over time. And the implementation of this process, we could see that, everything we talked about, like from the use of the plural component spray system to, making sure that they had like appropriate drying time for the facilities. This leads to about 35% reduction in hazardous waste from the facility, but also about 112,000 in the entire operating cost, from energy to labor to waste disposal. This is what we achieved over time. And also we're looking at reduced VOCs, usually around about 30% reduction in VOCs, because now they would have switching from manual painting into a much more automated spray painting process. So in conclusion, Lean itself is more about the people, the system, and technology involved. You want to make sure that you have the right staff, right empowerment, but also you set the appropriate guidelines for staff to follow, and you provide the necessary tools they're able to do their work. As long as you listen to the staff and you're able to understand what the root causes are and how to implement some of these tools, they would have achieved proper empowerment, and that helps them to do the job much more efficiently. And that would definitely deliver an avenue for reduced rate over time. So just to recap, we talked about Lean, we talked about our partnership, we talked about everything we did on the process assessments, value stream mapping, and the case study on Founder's Choice, what we did from energy efficiency, finishing process improvements, 5S and visuals, and waste management. And we talked about how providing these tools would help staff deliver an improved process over time. So that's the recap. I'd like to acknowledge my colleagues where I worked with from the Department of Ecology and also with Impact Washington. Definitely feel free to reach out and let me know if you had any questions.